There is this argument around the relationship between diagnosis and genomic surveillance. I was on a briefing with Africa CDC yesterday, and the data they were sharing indicated that in DRC, for instance, testing is just under like 20% in terms of suspected versus confirmed cases. They are just screening about 20%. So do you think that testing gap limits the reliance of genomic epidemiology? Or do you think genomic surveillance is still protected against the impact of limited diagnosis?
Yeah, I think that's a very good question.
I'm writing a piece on the Mpox outbreak on the continent right now, and there is a particular emphasis on clarifying the strains and clades. What's the difference between a strain and a clade?
Okay, thank you. So when you talk about clade, a clade is most likely a group of strain. So the strain is like a subset of clade, what a clade is. So it's like when you're talking about clade, in a simple term, to just look at them as, say, a country and then the state. So the country embodies the state. So, and that is how you should look at it. So in terms of look at it from a biological perspective. So clade is just a group of viruses, of strain that are possibly circulating in a particular location at a particular point in time. And then the strain are the mutations. I mean, I don't know how to explain it in a simple language, but I think the strain is just a mutation from each of that characterize a particular clade of that particular virus at that point in time. So that's the difference between a strain and a clade.
Okay, so why is this? What is responsible for these differences? Why do we have different strains and clades?
So the main difference is just the mutation that they have. So once there is an infection, the virus replicates. So during the process of replication, there is mutation that the virus accumulates over time. And for Mpox, we don't expect to see that much mutation, but because there is a protein within the human body that is inducing those kind of mutation, and that's why we are having a lot of mutation. So that's why the viruses are diversifying into several lineages and different clades. So this mutation that is basically driving the clades and the strains. But most of them we love to use the word lineages. Yeah.
You said that we don't expect too much of these mutations. Let's talk about the current area of mutations regarding the Mpox outbreak right now and their significance.
Yes. So so we have RNA viruses and DNA viruses. So RNA viruses don't usually have, when they replicate, they don't have this error proof. So that error proof is that they prevent mutation that will make it deleterious for them. So they don't have those correction mechanisms to correct any of those mutations that happens. So that's why you see a lot of mutation in RNA viruses, and that's why they are of pandemic potential. So, but for DNA viruses, which is why we have Mpox is part of those DNA viruses. They have this error proof. So during replication, they don't accumulate so much mutation like the RNA viruses does. And what that means is that they can spread within the population, but they don't have that pandemic potential of generating a new clade, a new strain, a new lineages very quickly, like we will see for SARS-CoV-2 or Ebola and the likes. So the reason why we are seeing that happening for Mpox is due to a protein in the human body called the ApoB3 protein, which is an antiviral factor. So what it does is that it targets a specific location within the Mpox genome. So it's a mechanism of defense for the human body. So what it does is that once there is an infection for Mpox, and when during replication of Mpox within the cytoplasm of a human, what happens is that the virus the protein or the enzyme try to destroy the virus. And during that process, it introduces this mutation. And thus, the way it tries to destroy the virus is by inducing mutation that will make it impossible for the virus to survive within the host. So that's why it's introducing those mutations into the virus. And that's why we are seeing. So we use this kind of mutation pattern to be able to distinguish between the viruses that are circulating in animals and the one that are circulating in human. Yeah. So because if we see those mutations in human, if you see those mutations on the Mpox genome, it means that this one has been in human. But if we don't see, if you don't see those kind of mutations, it means that this one is circulating among the animal population. So that's the significance of that. That's what it helps us to do at this point. Yeah.
We have different clades that are very popular. I think class 1, class 2, and I've been
Yeah.
seeing class 2B. So talk me through these ones.
So we have clade 1 and then we have clade 2. Now, clade 1, most Mpox cases historically has been that of clade 1, mostly in DRC in the 1970s. And because the reason why we have them was that was towards the end of the eradication program for smallpox. So we started seeing Mpox arise, mostly in children. And the reason why we see that in children 1970s was because those are people that are less likely to have been vaccinated for smallpox. But with time, Nigeria reported their first Mpox case in 1971, also among children. So they reported another one in 1978. So this one was in adults, but this adult came from Benin Republic, so somewhere in the southwest of Nigeria. And about over time, fast forward to 2017, 2018, we started seeing cases of Mpox in human, mostly in young adults between the age of 20 to 35. And then in Cameroon, we started seeing also increase in cases. In DRC, we have also been seeing increase in cases of Mpox. And also now the population is also starting to change from just children to mainly to adults as well. So when we started looking at it, so the next thing you need to do is to begin to look at what is going on between all of these, bring all these sequences together and ask the question, what is going on and how are they different? So that was when they realized that there is a difference between what is circulating in the West Africa and the one that are circulating in Central Africa and DRC. So they classified the one that was circulating. So initially they were originally called the Central Africa clade and the West Africa clade, right? But because WHO standard is that you don't associate location with an outbreak that is infecting everyone. So you have to make it a location agnostic. And that's why the name came up, clade 1 and clade 2. So the clade 1 are mainly circulating within the Central Africa region, and then the clade 2 are circulating within the West Africa region. So the clade 1 is more virulent. When I mean virulent, it means it has is fatal. So when people become infected with that, they are most likely to fall sick and they are most likely to die compared to clade 2. Clade 2 is less virulent and and that was the one that was circulated in Nigeria for a very long time. And then from 2017, 2018, we started seeing a pocket of outbreak of clade 2, the one that was circulating in West Africa, in the UK, the US, Singapore, Egypt. And then later on, in 2022, it went global and then everywhere became an issue. WHO declared it emergency of international public health emergency of international concern. And then later on, so there was so the people deployed, became aware of Mpox, they deployed vaccines and all. So it was people were able to, or the public health intervention was able to suppress this outbreak. But also at the same time, not too long, we started seeing increase in cases in the Central Africa. And that led on to clade 1A and then clade 2, clade 1A, clade 1B. And so the clade 1A are mainly the one that was zoonotic event. That means they spilled over from animals into human. And then the clade 1B are the one that are circulating mainly in human. That is sustaining human to human transmission. The same thing for clade 2. For clade 2, we have clade 2A, which is the earlier cases of Mpox that circulated mainly from animals and then making their ways into human at the early phase. Then the epidemic phase, that's when we have the clade 2B. Then the clade 2B was the one that was now sustaining human to human transmission. So the reason why all this nomenclature were given to them is because so that you'll be able to track the mutation that those viruses are accumulating and be able to track which of these children, or let me use the word children, lineages, that's the right word, lineages, so that you can track their phenotypic advantage, if they are more transmissible, if they are drug resistant, and if they are undergoing some recombination, so that we know at what point are we seeing this kind of pattern or some mutation that is conferring some phenotypic advantage to these viruses. So that's why. So I don't know if that makes sense. Yeah.
Come on, you can see I'm just smiling here. So I'm really enjoying every bit of that explanation. You've highlighted the differentiations and how these different strains are manifesting, whether it's a zoonotic spread or human spread, depending on the clade. What about outcomes? This is where I'm going to. If we want to tell public health, the argument might be whether it's clade 1 or whether it's clade 2, Mpox is going to be Mpox. So is that assertion true? And to what extent do you think delineating the genomic epidemiology could make a difference in control protocols?
Okay. I think the point is that, just like you said, I agree that it doesn't make any difference if it's clade 1 or clade 2. At this point, it doesn't make any difference, right? Because the epidemiology of this virus is extremely very complex. So just like you said, Mpox will always be Mpox. So the main reason why we have clade 1 and all these different clade and lineages is because so as to help us track what is going on as the virus is spreading, sweeping across population. And of course, I know maybe you've heard about the B.1 lineage. The B.1 lineage are the ones circulating in the West, in the global North, and in where the reservoir hosts were not present and where it has not been historically reported. And then why the clade, the A lineage are mainly on the continent of Africa where they are historically reported. Okay, so in terms of how will it help? All these things that we are learning now, we know using genomic epi to track all of this. How is it going to help? First is that it's going to help us to know where are the spillovers happening, right? So are they happening in the rural area? Are they happening in the villages? Are they happening in the city center? And it helps us to also track clusters of transmission. Are they sexual network? Are they people that are contacting each other? So how is it spreading? Is it transmitted around the household, or is it mainly is it occupationally driven? Is it sexual network driven? Is it household transmission? So this is what it helps us to unpack. And with that kind of information, you can help to target a specific public health intervention to those particular group of people. For instance, the work we did recently was able to show that so the virus peaked in 2015, right, and was spreading. And which state did that virus peak? It was in Rivers State, Nigeria, and was persistent for a very long time, spreading across all the south states, and then to the southeast, and then on and on. Like we also noted that most of the zoonotic events are happening between the border of Nigeria and Cameroon, and also states that are shared across that highly forested area of Cameroon and Nigeria. So people living in those areas can be specifically targeted, get them vaccinated, particularly people that are people that are less than 50 years old, right? Because people that are above 50 years old are most likely to have been vaccinated for smallpox. And smallpox confers some level of protection to people that are to Mpox, because they belong to the same family. So yeah, so this kind of helps help to be a very directed public health intervention. And also, what we have also learned from this is Mpox is, just like I said, Mpox have a very complex. It's not like it's spreading across population, so it's spreading across some specific subpopulation within the country, or anywhere it is spreading. So that's why it is very different. So you need to specifically target people that are at risk of it.
Yeah. So, quick question. There is this argument around the relationship between diagnosis and genomic surveillance. I was on a briefing with Africa CDC yesterday, and the data they were sharing indicated that in DRC, for instance, testing is just under like 20% in terms of suspected versus confirmed cases. They are just
Yeah.
screening about 20%. So, do you think that testing gap limits the reliance of genomic epidemiology? Or do you think the way genomic epidemiology, genomic surveillance like that you do is still protected against the impact of limited diagnosis?
Yeah, I think that's a very good question. Yeah, so there's what we call, okay, I will to answer you straightforward. So conventional epidemiology, it's just count cases, observe cases, right? But genomic epi overcome those challenges, even when you don't have all the cases figured out. But it is highly informative in the sense that it can help you to know what happened, even without you observing all the entire cases. It can help you to estimate what we refer to as the reproductive number. And reproductive number is simply how many infection is one person able to transmit, or how many persons is one infected person able to infect. And when it is above one, then it becomes a real problem. So once that reproductive number is above one, it becomes a real. So Mpox have a highly heterogeneous reproductive number depending on the context. So in some countries you go with this reproductive number is high, in some it is low. So it need to be the data coming from there need to be interpreted with the context. Yeah. So it does not really not having all the cases does not really hinder what the information that genomic epi is going to give you. But one thing is that there is a bias, and that bias is due to what we call ascertainment bias. So we are looking at where we are most likely to find them, right? So that's the main problem. But in terms of giving us a lot of information about what we know to take action, yes, genomic epi is enough. Even if you have just 10 sequences, it can tell you so much about what to do. All right. Compared to the conventional epi where you have to observe 20,000 cases to know that there is a serious problem. Even though it is good, but if you have 10 sequences, you can help you to know, okay, this is what we are seeing. Even though we don't have the full picture yet, but I think, yeah, it can give us a sort of idea of what to do in that kind of setting. Yeah.
So, which means even though many African countries are still not testing enough, but because of the genomic sequencing and genomic epidemiology capability available, we can still comfort people like you can still trust the data from genomic surveillance and still be rest assured of the outlook of the disease on the continent as far as we are concerned. Did I capture it very well?
Yes,
Okay.
I think so. Yeah, with what we have, I mean, the ideal would be to have the observe efficacies, alongside with the genomic data, right? It gives you a very nice picture. But in place where you don't, that's not what happens in real time, right? So, but at least if you are able to get some level of genomic data, I think you will be able to say, I think, to guide what to do next, going forward. I think so, and it doesn't, and that's why it doesn't really hinder what the information that is coming. As the information coming, you update what you have. You update what you have. For instance, there is a paper we published in 2023 that showed where we were able to establish the ApoBec protein being responsible for this transmission. In that paper, we estimated that Mpox was circulating in Nigeria as far back as 2016. Now we have more data. We went back to Nigeria, Cameroon, sequence more data, collect more data, and then do the sequencing. Re-estimated those. The threshold difference was just 8 month difference. Right? So which does not really change anything. So it means that the data we have at the moment and the one that are emerging from Sierra Leone is enough to make a real judgment of the situation.
I think that was actually the 2023 paper is actually this published in Science is actually on my mind. But I want to talk about your most recent paper, the one on genomics reveals zoonotic and sustained human Mpox spread in West Africa. So what did you do? What was the process like, and what did you find, so that we can talk about the implications of those findings?
Yeah, that's interesting. I think so what happened was that when Mpox happened and it went global, declared public health emergency of concern. So what we don't know is that we only knew what happened during that period when when it became a problem of the West. Right? That was when it mattered. It became something. Oh, so people say, oh, it came from Nigeria. At the same time, when Nigeria was experiencing increase in human cases in 2017, there was also a parallel outbreak in Cameroon around 2018 as well. So what we don't know is if the one that was going on in Cameroon is an extension of what is happening in Nigeria. And also we want to know the frequency of zoonotic events, how zoonosis is fueling this recurrent outbreak, because The outbreak has been persistent since 2017. And what is the impact of COVID, and where was the hotspot of that transmission, and what did we see? How did it, spread across the whole of Nigeria and went global? So we went back in time and consulted with Christian Happy, IGH, built a consortium of Pan-African Genomic to investigate this, to answer this question. And they retrospectively sequenced all the cases of Mpox that have been stored in the fridge in both countries, Cameroon and Nigeria, since 2017. But most of the sequences came from 2020, in Cameroon from 2018 to 2022, in Nigeria mostly from 2021 to 2023. So from those data, we were able to start the analysis. What we were able to show was that the hotspot of zoonotic transmission, particularly for the clade 2B, which is the current outbreak going on in Sierra Leone, is mainly within Cameroon and Nigeria. And then we were also able to establish that even though the first case of Mpox was reported in Nigeria in 1971, and from somebody that came in contact, it was a zoonotic event from animal to human, there is still a zoonotic event that is still going on in that same state, even in 2022. So that means that's about 50 years later, there is still an ongoing transmission in the same state. So we're able to sample, and we're also able to show that the outbreak in Nigeria was not just a different lineages from animals spilling over into human. It is just one. That same one that happened in 1971 is still the same one that led on to this massive outbreak that spread across the world. And then we're also able to establish that the one circulating in Cameroon is completely different from the one going on in Nigeria. And the epidemic dynamic in both countries are also different. In Nigeria, there is still zoonotic event going on in Nigeria. There is also human-to-human transmission is mainly driving what happened in Nigeria. But in Cameroon, it's a frequent zoonotic event, spillover from animals into human. Also, what we're also able to establish was, where was this virus in Nigeria? If the spillover has been happening for a very long time, where did it peak and started establishing into human-to-human transmission? We're able to now establish that first, since 2014, the virus started jumping into human and we're making occasional sporadic spread in human, but nobody noticed. But in 2015, that was when the virus started diversifying into all the lineages that we have today. But interestingly, what we found out was that the virus was in rivers. When it got into rivers, it's not like it was intentional, but it got to rivers and got lucky and jump into a mobile population. And those population was able to, share the virus among each other very frequently. And one thing I usually tell people is, if you go back in 2015, what was going on in Nigeria, I think it was an election year. So it's most likely what drove it. It was very opportunistic and then started spreading across population. So people that traveled, most of the exported cases were people that visited rivers during that period. The rivers, Delta, mainly the south part of the country. And then that was where the virus started spreading to Imo, Anambra, Enugu. And then later on, we started seeing a lot of export to Lagos, so many to Lagos. And then the later phase of the outbreak was in 2022 in the north central and then the northwest part of the country. So that's what the paper showed. And we're also able to establish that what are the factors responsible for all this massive spread that we saw. We realized that, just like what I was saying, that sampling bias, which is we didn't have enough of epic cases, so we only have genomics. So wasn't a determinant of, we have been seeing this virus in rivers. That was not the reason. It was not because the virus, the more sequences came from rivers. That was when we say that rivers is the epicenter, where the virus was persistent for a very long time. It wasn't because of that. So it was just gave us a very interesting picture of what happened and the cases where. So in terms of thinking about it, so it mattered if the virus came from rivers. It also mattered the kind of population that became infected, if you get what I mean. So, but we don't want to go too far, those kind of population, but that's what we were able to find.
Okay, thank you for that.
Yeah.
So, how different do you think what was spreading back then is different from what is currently spreading at the moment?
So at the moment in Sierra Leone is not different. So it's still the same, a continuation of what has been going on in Nigeria. So it's so if you look at the map of Sierra Leone and down to Nigeria, so it's different from the map between Cameroon and Nigeria. So it's really so. But if you look at what is going on in Cameroon in Sierra Leone, it's basically the lineage that have been circulating in Nigeria. So it's just that we don't want to say that the one in Sierra Leone at the moment is highly transmissible. No, it's not. It's just that maybe there is increased sampling, right? There is increased sampling. People are getting more aware of it and they are reporting to the hospital and the kind of places people are targeting to sample this thing. Maybe, yeah, that's what I refer to as settlement bias. So they're most likely coming to the hospital and all of that. So, and that's what makes it looks as if, oh, the doubling time is just 2 weeks and we're seeing a lot of cases. I don't think we should interpret it like that. So we should be careful in interpreting now. It's not more transmissible than what we've had before. Yeah, that's what I would say.
What about clinical impact?
Yeah, at the moment, the clinical impact is still relatively the same. I think the one that was different is the clade 1. So the clade 1 have a different clinical manifestation compared to clade 2. And that one is, that's what I say that the clade 1 is more fatal compared to clade 2. Yeah, so clade 2. And the reason why is because there is a gene deletion, the Mpox genome, that kind of separated those two lineages. So the gene that is responsible for the virulence is deleted in the clade 2 that is circulating in Nigeria, Cameroon, and that also went global. So compared to the clade 1, which is more fatal, people died more from clade 1 than clade 2.
So, is the gene the ApoBec3 or another gene entirely?
No. So the gene, the ApoBec3 is in human. So why the gene deletion happened in the virus itself?
Okay, thanks for that. Has there been any disruption in the modes of transmission across the clades?
No. So it's still the same. It's still you're most likely to to become infected when you come close to someone that is infected, basically, or share materials of someone who have been infected. Yeah. So I think basically that is it. There has not been any reports of change in transmission that I'm aware of. The clade 2 is the human to human predominantly.
So, clade 1 is the zoonotic
This is
transmission.
not it. Yeah, but also we have also started to see human to human as well in clade 1, characterized by the ApoBec that we see in clade 2. So it's just when this virus have the opportunity to manifest, they do. So they don't discriminate. Yeah.
No discrimination for viruses this time.
No discrimination. Yeah.
It's also important that we talk about it, which is the severity. If we look beyond genomics, presentation to the hospital is also a key factor in determining the outcomes. Do you think there is a uniquely genetic factor determining severity of this disease beyond just other clinical measures?
No, none that I'm aware of. I think the one that have been observed is in Cameroon for clade 2. I mean, that's why I said the epidemiology is really complex. So there is this family who became infected with Mpox, and then the clinical manifestation was very nasty, like really, really nasty. So much so that if you look at it, you say, "Oh my God, I think clade 2B is more lethal or more fatal compared to clade 1." So, but it's not true. I think it's basically depends on if people are immunocompromised. So they are most likely to manifest more symptoms because those family later found out that they were HIV patient. So that's why they had that kind of nasty severity. And then I think malnutrition, and so as long as you have a weak immune system, you are most likely to manifest unusual symptoms compared to someone that is immunocompetent.
We are seeing more cases and everything is rapidly evolving right now. So, what do you still see potential opportunities for genomic epidemiology? What information is still missing that would have a lot of difference in our understanding and ability to respond to Mpox outbreaks?
Yeah, I think from the genomic perspective, I think it's just sampling places that have not been sampled. But I think the one that would really, really interest me is going to those forests, and if possible, if can lay our hands, particularly the forested region of Nigeria and Cameroon and Abia State, if we're able to sample those animal population in those areas to better understand the diversity of Mpox in the animal population, that will really be good. And also targeting states where that is close to those forests. If there is any outbreak in those, even if it's one, they need to be sequenced. So, and because that will help us to get information around what are the diversity of these viruses, and do we have new ones that are more lethal or more that when they get to human will cause a lot of mayhem. So that would be the question that I'll be interested in at this point. And also, if there is any outbreak in any country, we need to sequence it and get that information as soon as possible.